Task 1, come together. Earth's tectonic plates sometimes move toward each other. As two plates of the same type of crust crash into one another, the plates buckle upwards to form high mountain ranges. This is called a convergent plate boundary. Earthquakes occur along this type of boundary, but usually not volcanoes. One place where this occurs is the Himalayan mountains. The process is slow, with the mountains growing in height about 5 millimeters per year. So I'm going to model a convergent continental boundary, plate boundary. I'm going to use 2 pieces of cardboard. And what I'm going to do is I'm going to push the cardboard together. And when I do that, you're going to see that it buckles to form a mountain. Task 2, separate. Some tectonic plates move apart very slowly over time. This kind of plate boundary is called a divergent boundary. Divergent motion usually occurs along the ocean floor. As the plates move away from one another, molten rock, magma, moves up from the mantle to the surface. When the magma reaches the surface, it is called lava. The lava cools and forms new crust material in the ocean basin. This area of new crust material between the moving plates forms a rift valley. Over time, the lava builds up to form underwater mountains which line the rift valley. While there is volcanic activity along the divergent boundary, earthquakes do not occur frequently. So what I'm going to do is I'm going to use 2 pieces of plastic. These are representing oceanic and oceanic crust, and I'm going to pull them apart because that's what happens at a divergent boundary, and you're going to see that it forms a rift valley. Task 3, move under. When tectonic plates containing different types of crust collide, the denser plate is pushed underneath the less dense plate. The process is called subduction. Since the plates are moving toward one another, the boundary is referred to as a convergent boundary. The high temperatures in the mantle melt the subducting plate to form magma. This magma is less dense than the rock around it and moves upward through the crust to form volcanoes. The motion along the convergent boundary causes many earthquakes. The Aleutian Islands of Alaska are a chain of volcanic islands which formed as a result of a convergent plate motion. Converging plates also formed the world's highest volcanoes, the Andes Mountains, located along the west coast of South America. So what I'm going to do to model a convergent boundary with continental oceanic crust is I have a piece of styrofoam that's representing the continental crust. You can see it's thicker, so it's more dense. And then I have a piece of thin plastic that's representing the oceanic crust, which is less dense. And all I'm going to do is push them together, and you're going to see that the oceanic subducts underneath the continental. Now this is going to form volcanoes in this area and then a trench right here. That's our 2 landforms. Task 4, slide on by. Some tectonic plates slide past each other. These boundaries are called transform boundaries. They do not destroy or build the Earth's crust. The motion between these plates results in many faults or breaks in the rock along the boundary. The San Andreas Fault in California is an example of a fault caused by this type of plate motion. In this area, the North American and Pacific plates are sliding past one another. As the rock material grinds past other rock, great stress builds, causing earthquakes. Earthquakes are very common along transform plate boundaries. In Southern California, there are about 10,000 earthquakes a year. So how I'm going to model a transform boundary is I have 2 pieces of plastic, oceanic and oceanic crust, and I'm just going to have them slide past one another, and you're going to see that it doesn't make a landform. All it's going to do in real life is there's friction along that boundary, and it's going to cause faults, which is, big cracks in the ground. It could also be a transform boundary where we have continental and continental, and it's going to be the same thing. We just have that rigid boundary where there's a lot of friction, and it's going to cause an earthquake, but again, no landforms except for the faults.